Hello, and welcome to this Illuminate Spotlight presentation about monitoring as code. I'll be your host. My name is Caleb. I work on the product team at Sumo Logic. Formerly, I was a co-founder and CEO of Sensu, which was acquired by Sumo Logic earlier this year. That's why I'm wearing a Sumo t-shirt and not a Sensu t-shirt. I'm a longtime open source contributor, very passionate about open source software. I live in Portland, Oregon, and I'm a pretty big fan of the Portland Timbers. You can follow me online at Caleb Haley on places like Twitter and Instagram and GitHub and whatnot. So today I want to give you a brief overview of monitoring as code, starting with how we got here. By the end, I hope to answer two questions, basically, why and how. Why as in, why is this important for my organization? And how as in, how do I get started? All right, let's start by looking at how the as code movement has evolved over time. The IT operations world has seen a lot of change over the last few decades. Although it's quite common to find CI/CD pipelines in basically every organization, it's still a relatively new concept. In the beginning, there was continuous integration, but CI was really only thought of as a development tool for testing and building applications, not automating other operational concerns. Everything changed around the time of John Allspaugh's 2009 talk, 10 plus deploys per day, and Jez Humble and Dave Farley's book a year later called Continuous Delivery. We realized we could do a lot more with CI than just build and test application code. We could also automate parts of the release process and deploy process, and thus the CI/CD pipeline was born. As a fun fact, legend has it that Patrick Dubois was inspired so much by this 10 plus deploys per day talk, among others, that he was motivated to launch the inaugural DevOps days later that same year in the fall of 2009 in Belgium. Before we knew it, the term infrastructure as code had also entered the vernacular. There's no canonical date for when that really began, but it became a major foundational element of the DevOps movement. Infrastructure as code enabled us as developers and operations engineers to increase velocity while improving reliability, repeatability, and maintainability. Lumping all these practices together under the umbrella of everything as code has been gaining momentum over the last few years. This first article, actually, you see here on the left, is a case study from Standard Chartered Bank. We'll double click on that in a second. There's also been a lot written about this in a bunch of other popular media outlets and from vendors like HashiCorp. So this slide is from Standard Chartered Bank, that same individual as that first screenshot we showed in the last slide, Sean Norris. This was given at the DevOps Enterprise Summit, the Gene Kim event in London a few years ago. And I just really love this slide because it shows how important everything as code has become. It's a key strategy being adopted by industry-leading organizations as one of the very important elements of a digital transformation initiative. Now, in most of these leading organizations, as code practices were already commonplace in engineering. And as those changes improved engineering velocity, then it became desirable, hey, wait, look at what we've done over here with our application delivery process, our application development, build and test process. How can we adopt these same practices of automation in other parts of the organization, specifically including IT operations? So now it's super common, as we said before, to find CI/CD pipelines in most companies, but it's in the adoption of as code practices in IT specifically where I think we encounter both the most challenges and also the most rewards. And even though everything as code has become a sort of status quo among these leading IT organizations, and many of them are already finding a ton of success with practices like infrastructure as code, the other operational concerns have lagged behind. So those advancements made in application and infrastructure delivery are way ahead of where we are at in terms of monitoring and observability. And the challenge now that's facing us as an industry and these organizations in particular is, the more time that passes when you have these parts of the organization which are under automation gaining in velocity and other operational concerns which are still not yet automated and managed via as code, there's like a growing gap. So how do enterprise IT teams catch up? This is where monitoring as code comes into play. So what is monitoring as code? It's part of a comprehensive everything as code initiative, as we've just sort of laid the groundwork for. It's a natural progression of as code workflows. And we didn't invent this. This is not a Sensu thing. It's not a Sumo Logic thing. This is something that leading organizations are already seeking or adopting solutions for around. Now, what's great about monitoring as code is that you can reuse your existing skills and tools. And you should have the same expectations for monitoring as code as you do for other as code workflows and practices. That includes things like, testability, sharing, self-service access, so on and so forth. I think the area where we at Sensu and now Sumo Logic are contributing the most around this movement is in the completeness of the solution. So monitoring as code should be an end-to-end solution, not just automation of collection of observability data. So to illustrate this point, the difference between infrastructure as code and monitoring as code, we'll show here a Kubernetes deployment template on the left next to a Sensu monitoring template on the right. Both offer support for managing resources and their various dependencies as code, and both templates are consumed by configuration APIs that then bring the corresponding systems into their desired state. But Sensu's monitoring as code solution isn't limited to the automated installation of agents, scrapers, and plugins, and basically then configuring the monitoring data collection. That would be more like infrastructure as code for monitoring. The example on the left here is a Sensu agent sidecar being deployed in Kubernetes. We would classify this as infrastructure as code, not monitoring as code. So with Sensu, you get a complete end-to-end solution for monitoring as code. This includes automated installation of plugins and exporters. That's the instrumentation, the scheduling and orchestration, the automated diagnosis, correlation and deduplication. That's a detection of anomalies and other incidents. The alerts and incident management, that's notifications, one of the key value propositions of monitoring, metric and event storage and analysis. So what do we do with the data once we've collected it? And we even go so far as to offer a solution for automated remediation that's not merely forwarding events to some external system to determine to let it determine what action should be taken, but we can actually codify remediation actions in these monitoring as code templates across any number of automation platforms and then directly integrate with them. So I can say, hey, if I detect a failure of this service, I have a solution for that in Ansible Tower or in Rundeck. Let's go run that job. What you end up with is an IT operations tribal knowledge effectively documented in a completely portable declarative template. It's all basically in a single YAML file. So in summary, monitoring as code isn't just about collecting data, it's an end-to-end solution. That's one of our key takeaways from this presentation. So now let's talk about what this means in practice. Why does this matter and how do you do it? Like, how do you actually put this into practice? Well, first and foremost, monitoring as code is an organizational initiative. That's really one of our second key points. And what do we mean by when we say that an organizational initiative? We want a unified workflow for IT operations and for IT innovation. So by bringing monitoring in line with the workflows and processes and tools that we're already using elsewhere in the organization to manage the rest of our infrastructure and application lifecycle, we improve communication between teams and overall velocity of the organization. One of my favorite ways to visualize this and help drive home the why is this completely arbitrary diagram that helps sort of explain why as code workflows have become popular, because they work. They have a huge impact on the technology adoption lifecycle. It's all about faster time to value. And if you look in this diagram at the yellow line sort of indicates the point at which we are getting value out of some technology investment. Now, traditional adoption lifecycles require a lot of pre-value investment. That's the initial setup, deployment, training, configuration, and so on before the thing is sort of working the way we want it to. And then if someone comes and looks over your shoulder and says, oh, that's really cool, how do I do that? They have to go through the same setup, training, deployment, and so forth to get that same value. Versus as code adoption life cycles, which are more about post-value investment, when that looking over the shoulder happens, you say, oh yeah, just clone this repository, and you can get exactly the point that I'm at. You can start there, more or less. And then as you onboard these new teams, they can just spend more time basically tuning those configuration templates for their needs, basically optimizing the system. This is, again, where that innovation happens. So like most successful initiatives, monitoring as code involves these three key ingredients of people, process, and tools. We're going to review these from right to left, starting with tools, which have until now been the missing link in the evolution of monitoring as code. So the new tool that has emerged to enable true monitoring as code is the observability pipeline. Why? What does observability pipelines have to do with monitoring as code? Well, all of these everything as code initiatives, as we've been discussing, are built on top of pipelines that enable organizations to codify complex business requirements as repeatable steps. The CI pipeline gave us build and test, continuous delivery, added deploy, infrastructure as code, then introduced provisioning into that step, and even some integration testing, so we could do a testing of that infrastructure before deployment. And now, like infrastructure as code, monitoring as code also is going to hook into the CI/CD pipeline for the initial deployment or of your monitoring configuration or changes to your monitoring configuration. But it also requires a dedicated pipeline for the ongoing observation of our system. So once we have taken the deployment step, now we have observability data flowing through the pipeline. That pipeline can then take those actions, that rest of that complete solution about how and when to process the data, where to route it, what actions to take, and so forth. So again, the missing link, the tool, is the observability pipeline. So this is what I would call a conceptual or generic observability pipeline. At a very high level, any observability pipeline architecture or architecture diagram you look like, if you squint your eyes, it's going to look more or less like this, where some data comes into the pipe. The pipe gives you some common capabilities like transformation and normalization of data. I sort of classify it as control, gives you a ton of control. Then you can route data to various backends or syncs. Different terminology will be used by different vendors or open source projects and whatnot. And these are only the functional requirements, though. None of this gets into the actual business requirements we'd have around security, reliability, and resiliency. Things like SSO, encryption, audit logging, high availability. How does it perform? How does it scale? Is it fault tolerant? What do I do if I have intermittent connectivity issues? There's so many features, which is why the DIY observability pipeline is more a question of, not a question, I should say, of can we, but more of should we. I grabbed this image from a really, really good blog post by Tyler Treat called The Observability Pipeline. I would encourage you to go and read that if you're enjoying this discussion. There's a ton of good ideas there. And yes, we can cobble together a bunch of tools and roll our own observability pipeline, but now more than ever before, there is the availability of turnkey observability pipelines such as Sensu. Sensu provides all the tools you need so you can focus on extracting value from your monitoring and observability investments. So how do we get started? This is one of my favorite quotes about digital transformations from Bask Iyer, the CIO at Dell EMC. I'll just read it. It says, "I need a roadmap I can rally people around and deliver against." I just love the simplicity of this statement, which describes a very complex thing which we live in every single day of our lives as folks in the technology industry, where I can sell you the most grand idea and get people really excited about some new technology. But if it's vaporware, I'm not going to be able to rally people around it. They're going to see through that really quickly. On the other end of the spectrum, I can build the most capable system that can actually deliver against all of these complex business requirements we may have. But if the solution is so complicated to use, I'm not going to be able to rally people around that. So we need something that's sort of in the middle. So how do we do that? Let's talk about the process. The typical journey to monitoring as code for most organizations follows 4 major milestones: integration, standardization, codification, and iteration. Let's first talk about integration. So the observability pipeline provides an integration layer. It basically is an integration tool between your existing as code tooling. So that's your CI/CD, your cloud or multi-cloud APIs, compute APIs, things like that, your secrets management, your certificate infrastructure, and other systems of record. Sensu provides built-in integrations to make reaching this milestone of integration really easy. You just go down the list to say, hey, we need to integrate with the X, Y, and Z systems. You configure those, and now you can immediately begin iterating on versioned monitoring code, unifying development, IT, and security around this shared workflow. The second step is standardization. What does this mean? I think I think of this as really a prioritization step where you're identifying existing instrumentation interfaces or basically other monitoring tools, which can be consolidated into a unified pipeline. That means, how many product teams inside the organization are still using Nagios, which ones are using Datadog, which ones are maybe using Prometheus, which ones have rolled their own monitoring with HealthZ endpoints. The list goes on and on. We can go and look at each one of those and say, hey, if we figure out a way to not do a complete lift and shift off of Nagios, but how can we allow you to reuse the plugins that you have grown to trust over the years and basically not throw the baby out with the bathwater? So we can reuse your Nagios plugins. We can take those metrics which you are sending to Datadog and route those through the pipeline. We can take the metrics which you're exposing as Prometheus exporters and get those into the pipeline. So and the way you prioritize this is you say, which one of these interfaces or tools had already gained the most adoption inside the organization. That's going to give you the largest blast radius. And then you just pick that thing, you prioritize that thing, and you sort of work team by team going around the organization and onboarding them into the observability pipeline and this monitoring as code workflow. The third step is writing the code. This is mostly configuration, as we showed in our screenshots earlier. This is when things get really interesting. We start packaging common monitoring and observability business requirements as these declarative monitoring templates. Each one that we add enables more accelerated adoption across additional business units because we increase the likelihood that, hey, I'm also using this service as part of our application stack. We already have monitoring templates for that. It becomes very, very easy to adopt and roll out. The fourth and final step is iteration. And this is where the innovation happens. And I have good news and bad news about this step, which is that it never ends. So by closing this everything as code loop in the application lifecycle, now basically the entire life cycle from the creation, modification of the product infrastructure is managed as code, and now the ongoing operations of that system managed as code. Now development, IT, and security teams can collaborate in ways where no matter what the improvement is that we need to make to the business, it's always going to be a code change. Even if that improvement now spans code changes in the application, code changes in our observability and our monitoring basically as code, or code changes maybe in some automation or remediation actions that we need to take advantage of to fill some gaps in our systems or whatnot. It doesn't matter what part of the organization it touches. We have now brought the sort of last final piece of the everything as code of our operations of our systems basically into that everything as code workflow. So we have this nice unified workflow. Finally, let's talk about the people. I couldn't find the perfect meme for this slide, so bear with me here, pun intended. But in all seriousness, Smokey the Bear is not the spokesperson for monitoring as code. There are no DevOps heroes here. One of the greatest benefits of as code workflows is that it helps codify things that may have formerly been tribal knowledge held by the relative few. So where that applies to other parts of the as code or other areas where we've applied as code workflows, it also applies to monitoring as code. So monitoring as code helps turn a who needs to be involved cost discussion into a who can be involved opportunity discussion. You can start with just a few engineers or maybe even just one, and then onboard more folks from development, security, and operations over time. The best part is most teams need little or no training. They can just look at the code examples and modify them to meet their needs. Think about how we learn. You go to a conference like this, you see a talk, that talk maybe has a demo. You say, hey, is the code for that demo going to be available after this talk? Because looking at that code and modifying it, that's how we learn. So the learning happens over time. Monitoring as code builds on this already. The other last nice benefit is that it builds on our already established common tool chain. That is our code tools. It's code. So your text editors, your code repositories, your CI/CD pipeline, basically it's all familiar tools and skills. And now you can invite new teams to contribute to this standardization, prioritization, codification, and iteration process. So following through those steps that we described earlier. So in summary, if you only take away 3 things from this talk, remember this. Number 1, Monitoring as code is an organizational initiative. It creates opportunities to get development, security, and operations aligned around a shared interest in the performance and reliability of your systems. Number two, monitoring as code isn't a lift and shift. It can be adopted over time, and that initial incremental iteration will quickly gain velocity because onboarding new products and teams becomes even easier over time. The more of the monitoring system, which you have example code templates for, or that you've brought under management as code, the fewer gaps there are when you onboard new teams. They're already going to find everything they need. And lastly, number three, monitoring as code is an end-to-end solution, not just a tool for automating the collection step of the monitoring. So modern monitoring as code is facilitated by observability pipelines. That's the key tool to remember from this. And that'll help you get even more value out of your investments into Sumo Logic. So speaking of investments, Sumo Logic's recent investment in the space by acquisition of Sensu makes Sensu's industry-leading monitoring as code solution available to all Sumo Logic users. To learn more about that, please visit sensu.io. You can join the Sensu community at discourse.sensu.io. And if you want to see maybe a demo of some of the things we've talked about today, or just one-on-one conversation follow-up about if you're interested in trying this inside your organization, you can fill out our contact form to schedule a demo and get in touch with our developer advocates and sales team and whatnot. If you're seeing this presentation before Tuesday, September 28th, you can see what this looks like in practice by attending one of my Illuminate workshops entitled Graduating to Monitoring as Code. There's a morning and afternoon session. Please come join me. It's going to be, there was way too much content to fit into this one talk, so there were no demos in this talk, but during that session, it's going to be like almost 90 minutes worth of demos and interactive hands-on. So if you're unable to attend one of those sessions, or if you're seeing this presentation after September 28th, don't worry. This exact same workshop will be available as a set of self-guided training materials. You can use at your own pace. We call it the Sensu Go workshop, and you can visit sensu.io/Sensu Go workshop to learn more about that. I really hope you enjoyed this presentation, and I hope you enjoy the rest of Illuminate. Thank you for your time and have a great day.